Moving on to the last topic on association mining. Here we will discuss about from association mining to correlation analysis and constraint based association mining. First we will see what you mean by correlation analysis and what is the difference between this mining. From association mining to correlation analysis. The reason behind this move is most association rule mining algorithms employ a support confidence framework. Although it excludes the exploration of a good number of uninteresting rules, many rules so generated are still not interesting to the users. Unfortunately, this is especially true when mining at low support thresholds or mining for long patterns. This has been one of the major bottlenecks for successful application of association rule mining. Therefore, support confidence framework can be supplemented with additional interestingness measures based on statistical significance and correlation analysis. So let's see how it is different from the representation for an association rule while we are also representing the correlation between this. A correlation measure can be used to augment the support confidence framework for association rules. This leads to correlation rules of the form we can represent A to B with support confidence dot correlation. So we are including one more measure, that is correlation with the support and confidence along with the association rule. That is, a correlation rule is measured not only by its support and confidence but also by the correlation between items A and B. There are several correlation measures to choose from which would be good for mining large data sets, including lift, chi-square, all confidence and cosine. These are some measures we can choose for correlation analysis. Lift is a simple correlation measure that is given as follows. The occurrence of item set A is independent of the occurrence of item set B if probability of A union B equal to probability of A into probability of B. Otherwise, item sets A and B are dependent and correlated as events. This definition can easily be extended to more than two item sets. Lift between the occurrences of A and B can be measured by computing the following equation. That is, lift of AB equal to probability of A union B divided by P of A into P of B. It is equivalent to probability of B conditioned on A divided by probability of B, or confidence A to B divided by support B, which is also referred as the lift of the association or correlation rule A to B. In other words, it assesses the degree to which the occurrence of one lifts the occurrence of the other. So this is a simple correlation measure that can be used to see the correlation between two item sets. Next one is chi-square method. We can analyze using chi-square. To compute the correlation using chi-square analysis, we need the observed value and expected value that is shown in the given table for each slot of the contingency table. For example, from the table 5.8 we can compute the chi-square value as follows. Chi-square equal to sum of observed minus expected whole square divided by expected. This is the equation for calculating the chi-square measure. And we can see the example as shown in the contingency table. We can see there are two items, video and game. Video and not video, like that, game and not game. We have values here, that is observed value of video, that is true case, we have 4000, and the expected value is given in the parenthesis, that is 4500. Similarly, video and game. not game, that is video yes and game not. That case we have 3500 observed value, and in bracket we have expected value. And note video and game, that is the next possible case. We have 2000 and the expected value is 1500, and next one is not video not game. So that is the case. Observed values we have 500 and the expected values are 1000, and we are calculating each sum of row wise and also column wise. That are the values here we are representing. You just see how we are calculating a chi-square value for this particular table. So here first one we are considering 4000 minus 4500 whole square divided by 4500, plus we are finding all the possible combinations. Then finally we get an value, that is 555.6. that is the chi-square measure we are getting from this particular example. Other correlation measures that can be used are all confidence and cosine. We will see where these kinds of measures are used. A measure is null invariant if its value is free from the influence of null transactions. So what is the null invariant? A measure is known as null invariant if its value is free from the influence of null transactions. That is, transactions that do not contain any of the items set being examined. Because large databases typically have numerous null transactions, a null invariant correlation measure should be used for this purpose. So that we are using all confidence or cosine measures. When interpreting correlation measure values, it is important to understand their implications and limitations also. Next we will see what you mean by constraint based association. The reason for using this particular kind of mining method, a data mining process may uncover thousands of rules from a given set of data, most of which end up being unrelated or uninteresting to the users. Often, users have a good sense of which direction of mining may lead to interesting patterns and the form of the patterns or rules they would like to find. Thus, a good heuristic is to have the user specify intuitions or expectations as constraints to confine the search space. This strategy is known as constraint-based mining. Here, the users can specify their expectations or intuitions as constraints for doing this mining process. That is known as constraint-based mining. The constraints can include knowledge type constraints, data constraints, dimension or level constraints, interestingness constraints, or rule constraints. Knowledge type constraints specify the type of knowledge to be mined, such as association or correlation. Data constraints specify the set of task relevant data. Dimension or level constraints specify the desired dimensions or attributes of the data or levels of the concept hierarchies to be used in mining. Interestingness constraints specify thresholds on statistical measures of rule interestingness, such as support, confidence and correlation. So we are familiar with all these type of constraints. And the next one is rule constraints. These specify the forms of rules to be mined. Such constraints may be expressed as meta rules, that are rule templates, as the maximum or minimum number of predicates that can occur in the rule antecedent or consequent, or as relationships among attributes, attribute values and or aggregates. So these are known as rule constraints. We will see how the use of rule constraints are using to focus the mining task. This form of constraint-based mining allows users to describe the rules that they would like to uncover. thereby making the data mining process more effective. In addition, a sophisticated mining query optimizer can be used to exploit the constraints specified by the user, thereby making the mining process more efficient. Constraint-based mining encourages interactive exploratory mining and analysis. So rule constraints can be again classified into 5 categories that are anti-monotonic, monotonic, succinct, then convertible and inconvertible. Constraints belonging to the first 4 of these categories can be used during frequent item set mining to guide the process, leading to more efficient and effective mining. Meta rule guided mining of association rules. We will see how the meta rule guided mining is happening. Meta rules allow users to specify the syntactic form of rules that they are interested in mining. The rule forms can be used as constraints to help improve the efficiency of the mining process. These rules may be based on the analyst's experience, expectations, or intuition regarding the data, or may be automatically generated based on the database schema. We will see an example of such meta rule. P1xy and P2xw. Then there is a chance of buying this particular customer office software. For instance, rule below matches or complies with meta rule above. Here we have age group of the customer, that is between 30 to 39, and income between 41,000 to 60,000. So there is a chance of buying office software. These meta rules can be used to guide the mining process. So we can represent such meta rules and this can be used for mining in an effective. We will see some more additional points on mining various kinds of association rules. We have studied different types of association rules that are single dimensional, multi-dimensional, multi-level association rules, and the Boolean type or the categorical type, like that. So we will see some additional points. If any question arises on the particular topic, you should add all these additional points under that topic. Mining frequent item sets and associations has been extended in various ways to include mining multi-level association rules and multi-dimensional association rules. Multi-level association rules can be mined using several strategies based on how minimum support thresholds are defined at each level of abstraction. We can use different strategies like uniform support, reduced support, and group-based support for doing this multi-level association mining. Redundant multi-level association rules can be eliminated if their support and confidence are close to their expected values based on their corresponding ancestor rules. Techniques for mining multidimensional association rules can be categorized according to their treatment of quantitative attributes. So we have two different categories. First, quantitative attributes may be discretized statistically based on predefined concept hierarchies. Okay, using concept hierarchies, we can discretize the quantitative attributes in the first method. Data cubes are well suited to this approach because both the data cube and quantitative attributes can use concept hierarchies. Second method is quantitative association rules can be mined where quantitative attributes are discretized dynamically based on binning or clustering methods. So here we are using the discretization method, and it is doing dynamically based on binning or clustering, where adjacent association rules may be further combined by clustering to generate concise and meaningful rules. So these are the additional points you can add under various types of association rules.